Everyone, this is another math video. We're going to go over chapter 7 review today, questions number 3, 5, 9, and 11. As you can see, question number 3 is a question about the properties of a couple of exponential functions. So we're going to look at, first of all, the a and b values of each one. So you can see the a value here is 125 and the b value is 0.78. And for question C here, this a value is going to be 1 and the b value will be 3. So in regards to the number of x-intercept, neither of these will actually have any x-intercept because they are exponential functions. So none and none. The y-intercept dependent, of course, on the a value, so 125 for question A and 1 for question C. The end behavior is always going to move from left to right. In both cases, it never goes below the x-axis, so therefore it will be quadrant 2 to quadrant 1 for both of these. The domain is going to be all real numbers. Again, for both functions, the range is always going to be positive. Now, the behavior of whether it's increasing or decreasing depends on the b value. If b value is between 0 and 1, it's going to be decreasing, so this is going to be a decreasing function. And the y equals 3 to the x is going to be an increasing function. Okay. The question that's not asked to sketch these, but if you did, here's what they will look like. Right, just very quickly, on the quiz or test, you do need to mark down the y-intercept. In this case, this would be 125. And for this function, it will just be 1. So a fairly straightforward question to start us off. On to question number 5. This question is about a Dawson city in Yukon, and its population after gold was discovered there during the gold rush. So you can see that the population goes up exponentially. And I was asked about this question by a few people during class, so I did want to clarify out through this video. The answer in the back of the book, and a kind of a nice way of doing this question, is to rearrange it so that every date represents kind of a quarter of the year. So if you take the April 1st date, that's going to be the initial time, and then July 1st will be 1/4 of the year after, because that is 3 months between April to July, and then another 3 months between October and July, so that will be quarter number 2, and finally January 1st will be the start of the third quarter. So if you go ahead and say that these are quarters of years, that's a good way to do this question. So if you were to do that using a graphing calculator, in order to find out the regression, you will go to Stats, Edit, and enter your data as 0, 1, 2, 3, and the population 1,000, 3,000, 9,000, and 27,000, which is what we did here. And of course, then you will set up your window, which we did 0 to 5 for the quarters, and 0 to 30,000 for the population, just so everything would fit inside. And then we can go ahead and go to Stat, Calculate. It is going to be exponential regression, so we do want the option 0 here. So I just press Enter, and then second L1, comma, second L2. And that actually gives us the exponential function y equals to 1,000 and then 3 to the x. Because as you can see, the initial value is going to be 1,000 and the multiplier is always just 3. So in theory, you can do this question. You can So if you use the calculator, So if you use a calculator to do this question, you will go to Stat, Edit, enter your quarters and the populations, set up your window, 0, 5, and 0, 30,000, just so everything will fit. And then you can make sure that plot 1 is on. Check the scatter plot to make sure that it is an exponential growth, which it is. And then you can go to Stat, Calculate, number 0, Exponential Regression, and then L1, L2. You press enter, and you get that y is going to be equal to 1000 times 3 to the x. So you can see that the initial value is 1000, so that matches what we have here, and there is actually a common multiplier of 3. So that's where the 3 to the x comes from. As for the domain and range, the quarters clearly will be greater than 0, because you cannot have negative quarters there, and the range will be greater than 0 as well, because you cannot really have a negative population. As for part C, mid-May is halfway between April 1st and July 1st. So you can say that x is equal to 0.5. For mid-August, it is halfway between July 1st and October 1st, so x will be equal to 1.5. So what you can do, of course, is you can go ahead, go y equals, and then go vars, statistics, and then go to equation and plot the regression equation. And then you want to calculate what is y equal to when x is equal to 0.5. So that will be 1732. And then same thing for mid-August, so you can second calculate value 1.5, and you'll see that population will be 5,196 people. And that's it for number 5. So if we continue on to number 9, this question here asks us for the properties of a couple of logarithmic functions. You can see that one of them is positive, the other is negative. So for the positive one, I have something that looks kind of like this. And for the negative one, I have something that looks like the reverse. Okay. Now for the x-intercept, both of these is going to be 1. There will be no y-intercepts for a logarithmic function like these. The end behavior, you want to be very specific because it's moving from left to right. So if it is positive, it goes from quadrant 4 into quadrant 1. And if it's negative, it goes from quadrant 1 into quadrant 4. The domain, you can see that it's going to be positive values because it does not include 0. And for the range, it's going to be all real numbers. Again, that will be a positive domain and all real number range for both of these logarithmic functions. Finally, the first one, of course, is increasing. And the second is going to be decreasing. So a quick rundown of number 9. Moving on to number 11 is a question about the depth of water and its relative penetration of sunlight. First thing that we need to do is to set up the list. So you go Stat, Edit, and you will notice that I switched L1 and L2 around. The reason I did that was because the way that it originally was arranged in the question, it will actually be a exponential regression question. But the book specifically says that it should be a logarithmic regression, so therefore the x and y need to be switched around. Unfortunately, the textbook was not very explicit in that regard, so I just want to mention that. during this video. But basically what you do after that is you can go to y equals, make sure plot 1 is on, you set up your window in the right way. This time x is going to be the penetration of sunlight, so it is L1, and the depth of water is going to be the y. As you can see, the x value is going to be a percent, so therefore it goes from 0 to 100, and the depth, we need it to be 200 for the question, so I'm going to let it be y max equals to 200. And then I can go to stats, calculate ln regression, and then L1, comma L2, right? And I get a regression equation that looks like this. So y is equal to 151.211 minus 32.837 ln x. Okay, and I'm going to go ahead and graph this. So I go vars, and then number 5, statistics, and the equation to put that in. And I want depth to be 200, so y equals 200. I'm looking for an intersection here, so I'm going to go ahead and graph. You can see that our regression equation actually goes through all the points that we plotted earlier, and there's my line y equals 200, so I simply go second, calculate, and then number 5, and I can find the intersect just by pressing enter. And so when y is equal to 200 meters, x is equal to 0.226%. And that's it. So that's the end of the video. Hopefully it has helped you review for chapter 7 ahead of Monday or Tuesday tests. So good luck studying, and I'll see you guys then.